NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math tutorial. Today we're going to learn how to solve incomplete quadratic equations. Specifically, we'll be focusing on a special case where the constant term c equals 0. Let's start with the general form of a quadratic equation. A quadratic equation in standard form looks like ax squared plus bx plus c equals 0, where a, b, and c are constants and is not equal to 0. In this tutorial, we'll specifically focus on the case where c equals 0, which creates what we call an incomplete quadratic equation. Let's look at the algorithm for solving this type of equation. When c equals 0, we follow these specific steps. Step 1, we start with our standard form quadratic equation. Step 2, we substitute c equals 0 into our equation. Step 3, we simplify the equation by removing the 0 term. Step 4, now we can factor out x from each term in the equation. Step 5, we apply the zero product property. If a product of factors equals 0, then at least one of the factors must be 0. Now, let's see an example of how to apply this algorithm to solve an incomplete quadratic equation. Consider the equation x squared minus 5x equals 0. Let's solve this step by step using our algorithm. First, we identify that this is already in the form where c equals 0. In this example, a equals 1 and b equals negative 5. Now we can factor out x from both terms. Now we apply the zero product property. Either x equals 0 or x minus 5 equals 0. From the second equation, we get x equals 5. So the solution set for our equation x squared minus 5x equals 0 is x equals 0 or x equals 5. We want to solve the equation x minus 1 times x plus 1 equals x minus 1. The first step is to multiply the factors on the left side. So x minus 1 times x plus 1 equals x squared minus 1. This is because we're using the formula a minus b times a plus b equals a squared minus b squared. In this case, a is x and b is 1. Now, let's rearrange the equation to standard form by moving all terms to one side. We get x squared minus 1 minus x plus 1 equals 0. The plus 1 and minus 1 cancel out. So we have x squared minus x equals 0. Next, we can factor out the common term x from the equation. This gives us x times x minus 1 equals 0. Now, we can use the zero product property, which states that if a product is 0, then at least one of the factors must be 0. So either x equals 0 be 0. So either x equals 0 or x minus 1 equals 0. So our solution set for the first equation is x equals 0 or x equals 1. Let's verify our answers by substituting them back into the original equation. Now, let's move on to our second example. We want to solve the equation 5x squared equals 2x. We want to solve the equation 5x squared equals 2x. First, let's rearrange the equation to standard form by moving all terms to one side. We get 5x squared minus 2x equals 0. Next, we can factor out the common term x from the equation. This gives us x times 5x minus 2 equals 0. Now, we can use the zero product property again. Either x equals 0 or 5x minus 2 equals 0. If 5x minus 2 equals 0, then 5x equals 2, and x equals 2 over 5. So, our solution set for the second equation is x equals 0 or x equals 2 over 5. Let's summarize what we've learned about solving incomplete quadratic equations. First, we rearrange the equation to standard form by moving all terms to one side. Second, we factor out common terms. We need to solve the quadratic equation 3x squared plus 18x equals 0. To solve this equation, we'll use the factoring method. First, we notice that both terms share a common factor of 3x, which we can factor out. When we have a product equal to 0, we can apply the zero product property. This property states that if a product of factors equals 0, then at least one of the factors must be 0. Now, we have two simpler equations to solve. The first equation gives us x equals 0 as one solution. For the second equation, 3x plus 18 equals 0. We subtract 18 from both sides to get 3x equals negative 18. Then we divide both sides by 3, and we get x equals negative 6. Therefore, The solutions to the equation 3x squared plus 18x equals 0 are x equals 0 and x equals -6. Let's move on to our second example. Here we need to solve the quadratic equation -2x squared plus 16x equals 0. Again, we'll use the factoring method. First, we factor out the common term x from both terms. Now we apply the zero product property. If a product equals 0, then at least one of the factors must be 0. The first equation gives us x equals 0 as one solution. For the second equation, -2x plus 16 equals 0, we subtract 16 from both sides to get -2x equals -16. Then we divide both sides by -2, and we get x equals 8. Therefore, the solutions to the equation -2x squared plus 16x equals 0 are x equals 0 and x equals 8. Let's visualize these solutions with graphs. For the first equation, 3x squared plus 18x equals 0, we can plot the function y equals 3x squared plus 18x. The x-intercepts of this graph are at x equals 0 and x equals -6, which are the solutions to our equation. Similarly, for the second equation, -2x squared plus 16x equals 0, we can plot the function y equals -2x squared plus 16x. The x-intercepts of this graph are at x equals 0 and x equals 8, which are the solutions to our equation. Did you notice a pattern in both examples? We have the quadratic equation 4x squared minus 8x equals 0. Our first step is to factor out the greatest common factor. We can see that both terms have a common factor of 4x, so we can factor it out to get 4x times x minus 2 equals 0. Now, we'll use the zero product property, which states that if a product equals 0, then at least one of the factors must be 0. So we have two cases, either 4x equals 0, which means x equals 0, or x minus 2 equals 0, which means x equals 2. So, our solutions for this equation are x equals 0 and x equals 2. Now, let's move on to our second example. We have the equation x plus 2 times x plus 3 equals 6. Our first step is to multiply out the left side of the equation. Using the FOIL method, first, outer, inner, last, we multiply x plus 2 times x plus 3. This gives us x squared plus 3x plus 2x plus 6, which simplifies to x squared plus 5x plus 6 equals 6. Now, we'll move all terms to one side of the equation. We subtract 6 from both sides to get x squared plus 5x equals 0. We can now factor out the common factor x from this equation. This gives us x times x plus 5 equals 0. Again, we'll use the zero product property. Either x equals 0 or x plus 5 equals 0, which means x equals -5. So, our solutions for this equation are x equals 0 and x equals -5. Let's summarize what we've learned when solving incomplete quadratic equations. First, try to factor out any common terms. Second, if the equation is in the form of a product equal to 0, apply the zero product property. Third, if the equation isn't in the right form, you may need to rearrange it first by expanding expressions or moving all terms to one side. These methods allow us to solve many quadratic equations without using the quadratic formula. Let's start with our example. We have the equation, the quantity 2x minus 1 squared minus the quantity x minus 1 squared equals 0. Step 1. Let's expand both squared expressions. For the first term, we'll use the rule that a minus b squared equals a squared minus 2ab plus b squared. So the quantity 2x minus 1 squared expands to 4x squared minus 4x plus 1. Step 2. Now, let's expand the second term. Again, using the perfect square formula, we get x minus 1 squared equals x squared minus 2x plus 1. Step 3. Now, let's remove the parentheses and combine the terms. We use the distributive property to distribute the negative sign to each term in the second expression. This gives us 4x squared minus 4x plus 1 minus x squared plus 2x minus 1. Step 4. Now, let's simplify by combining like terms. We combine the terms with the same powers of x and constants. 4x squared minus x squared equals 3x squared. Negative 4x plus 2x equals negative 2x. And 1 minus 1 equals 0. So we get 3x squared minus 2x equals 0. Step 5. Let's factor out the common factor from the left-hand side. We notice that both terms have a common factor of x, so we can factor it out. We get x times the quantity 3x minus 2 equals 0. Here's the system of equations we need to solve. We have two equations, x equals 0 and 3x minus 2 equals 0. Let's think about what this means. Let's verify this by solving the second equation ourselves. To solve this equation, we need to isolate x. First, we add 2 to both sides of the equation. This gives us 3x equals 2. Now, we divide both sides by 3 to isolate x. This gives us x equals 2/3. So we've confirmed that the second equation gives us x equals 2/3. Today, we'll explore the conditions for a quadratic equation to have x equals 0 as one of its roots. Let's start with our example. We want to find the values of m that make x equals 0 a root of the quadratic equation. 3x squared minus 6x plus m squared minus 3m equals 0. Before we dive into the solution, let's recall what it means for a value to be a root of an equation. When x equals 0 is a root of an equation, it means that substituting x equals 0 into the equation makes the equation equal to 0. Let's use this concept to solve our problem. First, we'll substitute x equals 0 into our original equation. Great! Now we have a simplified equation in terms of m only. Let's factor this expression to find the values of m. The expression m squared minus 3m can be factored as m times quantity m minus 3 equals 0. Now we can use the zero product property. When a product equals 0, at least one of the factors must be 0. So either m equals 0 or m minus 3 equals 0, which means m equals 3. Let's verify our answers by substituting them back into our original equation. For m equals 0, our equation becomes 3x squared minus 6x plus 0 squared minus 3 times 0 equals 0, which simplifies to 3x squared minus 6x equals 0. Let's factor this. 3x times x minus 2 equals 0. This has roots x equals 0 and x equals 2. So indeed, x equals 0 is a root when m equals 0. For m equals 3, our equation becomes 3x squared minus 6x plus 3 squared minus 3 times 3 equals 0, which is 3x squared minus 6x plus 9 minus 9 equals 0. This simplifies to 3x squared minus 6x equals 0, which is this x equals 0, which is the same as before. So, x equals 0 is also a root when m equals 3. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.